So this is a presentation covering off less an interesting application of Arcadia or Capella itself, and more how we've managed to integrate Capella into a broader digital application, and taken advantage of some elements of the Arcadia method to help us build a truly digital application that allows us to analyze data from multiple different tools all at once. Or put another way, the golden thread. And examine the trace from any piece of data, for example, requirements or safety information, all the way through to the very lowest level information, like an asset or a design parameter, or a key design parameter, as we call it, associated with an asset. So what we have, we called this thing RESAN, mostly because we wanted people to think of it as showing you the reason why things are as they are. And we decided that would stand for Requirements Engineering and Safety Assurance Network. Yes, it's a bit of an invented acronym, but you haven't really done your job for the day until you've invented an acronym. And the network here is the network of information, the digital information that we need to deal with. The first thing that I want to cover off is the digital pyramid. Now, this is not a capability pyramid. If it was, we'd probably start with something sensible like processes, but this is not that. This is my view of what a digital pyramid looks like in terms of building a truly digital application. And by digital, just to be very clear, what I mean is the analysis of data rather than the use of computerized tools. So we start at the very bottom level with making sure that we've got a network and a decent computer and a decent set of servers and IT, our personal IT for people. Then on top of that, we need to build up our core business, or in our case, engineering infrastructure. And then on top of that, then we can start building up our specific engineering tooling, and we can start integrating together the engineering tools. This is not digital quite yet. This is just using computerized equipment and having them talk to each other. We can then, on top of that, we can start to build the data schemata, as well as the workflows and the defined processes that we might be using, built on top of all of this engineering tooling. And this is where we're starting to move into the realm of digital. And as we get more mature, we can then start building reference models, and templates, so we can start to organize the way that we have structured our information in our projects. We've built up an ontology at this point, and all the data is working together. So it's at this point that you can start to really start to analyze the information in its own right, rather than have to deal with a number of different tools. And so built on top of that, you can then start dealing with things like task automation and do your document generation, report generation, and potentially also automatic generation of some architectures. And then at the very top, we've got the really interesting stuff, which is not quite what I wish to talk about, but there we go. There's my view on a digital pyramid, stepping through levels of maturity. So we'll come back to that in a moment. But I needed to lay that groundwork so I can now explain where RESAN fits in. So RESAN, so what we're trying to do here is we're trying to tie together requirements engineering tools like doors that contain requirements and safety information. And we're working in the infrastructure space. So design typically means 3D modeling and BIM tools like Revit, 12D, MicroStation, Plant 3D, that sort of thing. Model-based systems architecting, so that's where Capella fits into the picture. And we've got a variety of other digital tools that might be of interest to us. So from a tooling point of view, we can see here that what we've done with RESAN is we've built ourselves a web front end, we've got a bunch of Python scripting, and we use Bentley ProjectWise to act as the, if you like, the configuration management tool in that regard. Doors Next Gen is what we've integrated with from a requirements management point of view, a range of different design tools. There are various digital engineering tools that have helped us along the way. And then from the model-based systems architecting point of view, it's mostly Capella, a little bit of Genesis mixed in along the way. So what does that actually start to look like when we start to try and integrate some of these things together? So we have obviously we've got tables and tables of data coming through from doors for the requirements and the safety assurance information. We've got a load of PABs with the functional chains displayed on them from Capella. We get the 3D models from the design tools, but we also get the 2D schematics as well. And what we've tried to do is we've tried to pull all this together into a single web interface where everything is related. So you can click on one thing and have everything else filter relative to that, which is very powerful because we're looking at things genuinely from a multitude of different viewpoints here, from data, 2D, 3D, viewpoints, safety requirements. So the ability to click on something and have everything else filter allows us to do that model-based systems engineering goal of being able to look at the project quickly from multiple different perspectives and see things that you wouldn't ordinarily see from a single perspective. So what does that mean? Well, that means that RESAN fits into these three layers here in the digital pyramid. So we need to integrate the tools together in order to work together properly and actually have all the information integrate. That's where the real secret sauce is. Making sure that we've got the right data schemata and the right workflows, and we've planned out all of our activities to make sure that we've got our data that will actually talk and integrate together. And we've enabled ourselves now to, now that we've learned what all the patterns are, to start working on reference models for the future as well. So that's where we see RESAN fitting in. So the use cases for such a tool. So we've got a number of different use cases here. The most obvious one is requirements impact analysis. So if somebody wants to change a requirement, we can show all the things that requirement is traced through to. And then we can look from the bottom up as well. If somebody wants to make a change during construction phase or in through life support, an asset needs to be replaced, well, we can show you everything that's connected to that asset as well. Safety case support, the tooling is there available to show which assets are involved in relative to which hazards, what safety requirements are traced to what, and what's involved in mitigating various safety issues. Part of what we need to do in order to make this useful is capture a large amount of information about key design parameters related to each of the assets. And so that then naturally lends itself to being able to initialize the effort to capture the technical specifications for each of the assets for procurement. It also allows us to then seed asset management information systems. And by virtue of the fact that we've got all the information now in one place, we can do other things like requirements dashboarding and various traceability views. So from a requirements impact analysis, one of the major use cases, looking through our interface here, we can see at the top here, we've got a requirements traceability view. You're definitely not meant to be able to read that writing, so don't worry about it. And we've actually got a slightly more updated interface, which we'll see in a minute. Then underneath that, we've got the 3D view of the world, where we've pulled in the models from the designers. And then we've got this table here with all of the assets, subassemblies and subsystems listed out. And then we've got a little window there that allows us to peek into the key design parameters. And then we've got a space here where we can show 2D system models and also schematics. And then finally, we've also got a little summary graph, and we can set that up to do what we want with it. So design change is very much the same, except we're now essentially using it in reverse. So we'd start by picking out a particular component. investigating how it fits into various functional chains through the system, and then we can explore the traceability from each of these elements back up to requirements and hazards and so on. You might be able to see that we've got a couple of little tabs up the top there. So we've got a different tab for each different sort of major use case. So we can move onto another tab, and then up the top, we've now got a hazard log view, which again is traceable, clickable, all of those things as well. Okay, so having talked about some of those use cases, how have we actually put it together, and how does Capella fit into the picture? Capella is absolutely central to making this work, and Capella is central to making this work because what we have is all of the requirements information, all of the safety information, tracing through to the system model. So that's an important step. And then each of the different components in the system model, they then trace out to the various elements that the designers have designed in their design/BIM tooling, and they've also captured all of the relevant sort of key design parameter information as well. So the first choice I think we made here was to use Capella. So why did we use Capella, and why is it the right choice for this sort of application? I certainly have experience in using other tools like Genesis in the past, but Capella is the right tool for this job. And it's the right tool for this job for a couple of different reasons. One, functional chain modeling paradigm is absolutely critical to helping us understand how the various elements of the system all work together to satisfy a requirement. And that then helps us manage the traceability between the system model and the requirements model. Next, there's a lot of data moving around behind the curtains to make all of this work, and the ability to use Python for Capella, which is such a powerful tool to help us with complex import and export and manipulation operations, is absolutely critical. It helps us make the tooling do what we need it to do. A number of other tools out there just simply don't have. The next is the REC and RPL paradigm. This is going to be very useful for us as we work through reference models and can start following the patterns that we've learned in pulling together the system model the first time, and then start replicating that again and again. Infrastructure models tend to have architectures that are quite repetitive because we're building the same thing again and again and again for each different building, for each different room, or along a train line, things get repeated. So REC and RPL, very, very useful. So let's have a little bit of a closer look at how we actually use Capella in RESAN. So what I've got here is a very, very simplified, and might be missing a few bits, but for the purposes of this presentation, I think this is good enough. So what we have here is a simplified HVAC system, and we could have used any other sort of basic infrastructure like subsystem. We could have used CCTV, passenger information. We could have used electrical distribution. In fact, we have a little bit here. Because the pattern is more or less the same. There's an endpoint somewhere. There's a connection from that endpoint back to a local central element, and then a connection from that element somewhere outside the scope of the project. So what we can see here is we've got three functional chains, one to supply cool air to a room, and then in the red we've got ventilate stale air from a space. And in the green, we have distribute power to the HVAC system itself. So as we look at the functional chains here, we've got air coming from the outside environment going to the cooling subassembly, which then goes to the air supply subassembly, which contains all of the assets that you need: an air handling unit, ducting, and the air vent or air terminal, as it's called, to supply air to the room. And then from the room, we've got the ventilation subassembly, and then venting air back out to the environment. In the meantime, the power system here. It's got that outer scope connection to the grid power, connecting to the main switchboard, which then connects to the mechanical switchboard, which then connects to the cooling subassembly. We can see that each of these functional chains represents a thing that the subsystems do. And what they've done is they've now tied together these various sort of subassemblies. And I keep using the term subassembly. When I say subassembly, I'm talking about something that is less than an entire subsystem, but more than an asset, right? So it's that how we organize the subsystem, that architecture view of each of the different subsystems. And we can see that each of these functional chains represents a thing that the subsystem does. And it shows us how the different subassemblies work together to help the subsystem achieve that thing, right? What that means, of course, is that they trace quite naturally to the subsystem requirements, in particular the functional ones. So so each of the subsystem level requirements, they trace to the functional chains, and further to that, we can also pick the top level requirements, and that then traces naturally to the compound functional chain, which includes each of these different subsystem level functional chains to show how the system as a whole, the infrastructure system as a whole, works together to achieve the top level requirement here of providing livable working accommodation for the entire system. So we can see we've got low level requirements, high level requirements, low level implementation, and high level implementation. This sort of shows how everything ties together. So we've got requirements coming in, and also safety data as well, and that traces through to the functional chains. And the functional chains, through the allocation of the functions, show us the relationship to the subassemblies, and then the subassemblies are the parents of the assets. So what that means, if we have a look here at the basic breakdown structure that we use, we've got the subsystem at the top level, followed by subassembly, followed by asset. And what that translates to is something a little bit like this. So underneath the HVAC system, we have a number of subassemblies here. So here, the ventilation subsystem, which includes the air terminal, the ventilation duct, and the fan. And we've got the air supply subassembly here, which includes the air conditioning or cooling to air handling unit duct. We've got the air handling unit, we've got the air handling to the room duct, and then we've got the air terminal at the end there. If there's any HVAC engineers on the line, I do apologise if I have designed something that is fundamentally wrong, but it's pretty useful as a little example. So then, in addition to that, what we can capture in the model by using the property values management tool and defining a property set and all of the properties, what we can start to do is then we can start to capture those key design parameters related to each of the individual assets. So we can see here we've got input voltage, output voltage, power rating, and you can see that the way that we've done it is we've used generic names for the property value variables, and that means that we can capture different key design parameters for each of the different assets. That's quite important. All right. So obviously there's a bunch of information there that we need the designers to capture for us. And so what they do, and they're used to doing this already, so that's kind of handy, is capturing metadata in their models. Every designer and infrastructure needs to capture metadata in their models for one reason or another. So all we did was said, can you capture a little bit more for us, please? Can you capture the key design values that you've calculated? You should already have that because you've done the design. Just please capture it in the model as well. So they're able to do that against each of the 3D elements, and they can also do that in the 2D schematics as well, which is great because it then helps us tie in the 2D schematics as well as the 3D modeling into the tool. So next, I have just a little bit of a video which I'll talk through, which introduces the example that we use. So here we've got a very much generic pump house with a substation next to it. So this is just our a very small example. And we can see we've got a couple of transformers outside the substation there. We can see we've got some air conditioning units. We can also see some fans and some lights and some emergency lighting, and the brown elements are high voltage equipment cabinets as well. You can even see a little fire extinguisher there. So that's the little example that we use when we're showing off what RESAN can do without exposing our customers' information. And we'll see in a moment just a little bit of the interface. So this is what it looks like. We can see the 3D model. We can see the components table, and we can see that we've got Capella models, and we also use the property values management and the diagram styler to show additional information like potentially impacted components. So each time we click on a subassembly or something like that, or an asset, we can then bring up the component information, and then this is our slightly snazzier requirements view of the world. We can click on a requirement, and we can see that everything else filters relative to that requirement. And as we scroll down again, what we can see now is that we've got a different set of things selected in the 3D model, all related to that top level requirement that was selected. We've got a different set of components selected as well. So that's just a very quick introduction to the tool. Now we'll have a slightly longer look at the interface, which I will now drag across. Okay, so hopefully you can see that okay. So this is the same example. You can see the interface here, and we can do all sorts of interesting things that are sort of typical of this sort of tool. We can do sections if we wish. I won't do too much of this. So we can sort of get a sort of slightly more cut down view of the world. We can color potentially impacted elements, so we get an instant sort of visual representation of things like that. And down here we can see we've got a set of different system diagrams. Now in our real project, we also have a set of schematics that exist in the same interface. So I'll just clear the filters here. So this requirements quad is pretty neat. We've got a set of we've got high level requirements, low level requirements, safety requirements, and then change proposals. And what we're able to do again is just click on something, and we can see straight away everything else is filtered relative to it. So we can see here that we've got all of the high voltage equipment. We've also got the air conditioning identified, and the external units because I've selected the air conditioning units for the substation requirement. We can see just the subsystems and subassemblies and assets that are actually related to that particular requirement, and we can see a smaller set of system models here, 5 instead of 11, and it's all clickable. So and this is something else that we've used out of Capella, which is really useful. We've used the XHTML export to be able to generate clickable images that then which we can then take advantage of. So I can now click on this transformer subassembly. I've now got again a different set of diagrams, and I can select the precise transformer here, and we can see all of its key design parameters here, just like the slide. We can see all of the requirements, so they've changed their filtering again relative to the transformer, and that's all driven through the traceability from the asset up to the subassembly through the functional chain, then into the requirements and on. And we have a look at the hazard analysis tab. We can also see the the relevant entry in the hazard log that is related to that transformer. Okay, so so there we go. That's if you like, a very quick view of what we've been able to achieve. Hopefully you can see how central Capella is to what we've done, because none of that joining up of the BIM models and the requirements and safety data is possible without the system model in the middle. So if I get that out of the way and come back to the slides, got one or two more slides to go. I think this might be the last one. Lessons, sort of successes and opportunities. So broadly, I sort of saw this in three categories: organizational / planning, technical, and value. All right. So from to begin with, organizational and planning. You might think that when you're trying to introduce something new onto a project that by and large people would be standoffish. And this wasn't the case. I was pleasantly surprised that when you can show designers the power of the tool and what it can do for them, in terms of traceability, they were very keen to help contribute, which was a fantastic experience. Having said that, making sure you've got budgets for them to enter in the metadata and so on, very important. So we made sure that early on we had put the right hooks in all the right plans. Next, again, because it's new, people will tend to go off and do what they've always done rather than the new thing. So maintaining good lines of communication is very important when introducing something new, and RESAN is no different in this regard. From a technical standpoint, an agreed ontology, absolutely critical in getting this to work. Why? Because at least in infrastructure, there are many disciplines, probably a lot more so than you might encounter in a software-centric complex system. And making sure that everybody is on the same page and calling things the same things between 10, 15 different design disciplines, plus the reliability team, the safety team, the systems engineers, is absolutely critical. So getting a good system breakdown structure and a naming convention, very important. Next, what we've learned is that RESAN is actually really quite adaptable because of the way that we've done it, and we've built a true digital application rather than an integration of tools. It means if somebody wants to see a different golden thread, we can show them a different golden thread. That actually reminds me, there was one small thing that I did wish to show off that I missed, so I'm just going to go back to that very quickly. And that is the data export feature. So in the interface, we've seen how we can show the different viewpoints, but what if you want to see a relationship that is different or perhaps not easy to show off in a web interface? Well, we've also got this little data export feature that allows us to identify each of the objects in our schema and identify that we wish to see them traced from one to the next. So we've done that, and that allows us to produce neat little exports. So it's effectively a choose your own adventure sort of traceability table. You can pick whatever you want to see, trace to whatever is important to you, whatever golden thread or digital thread is important to you. We can pull that information out as well. So let's get that out of the way. Back to here. And okay, next, value. It was really interesting to see how the customer reacted to what it is that we were doing, and it really sort of spurred us on to not forget about them, the digital thread and the golden thread. They're wonderful concepts for doing design and making sure that you haven't missed anything, and helpful for proving you built something that's safe. But then the customer was really excited about the asset management and through life support possibilities. So that was really great to see. And then the obvious extension of that is that what we saw was that depending on the role people had, they tended to be interested in different perspectives. Obviously, the systems engineers, they were more interested in the requirements. The designers, they were more interested in the 3D models and showing traceability there. It was a challenge for us introducing this for the first time to show value early, and I think that a focus on showing requirements traceability early probably helps in this regard, because that's what's best developed, whereas the designs might be very approximate, and people know they're going to there's going to be an amount of change with respect to the early design versions. So it would seem to make sense as you're building this data model up, that you start with the things that are mature early, then you move on to the things that are mature a little bit later, so then you can move on to the subsystem architectures and so on. And the further you go through the life cycle, the longer and longer the digital threads, and therefore the more value the tool tends to show. So there we go, that was my last slide. So I hope you found that interesting in terms of how it is that we've used Capella as a central element to a sort of more a broader digital tool. So I guess if you have any questions, please.
All right. Yeah, thank you very much, team, for this presentation. So we have a first question here. So what is this interface coded in with? Is it a web page? That's web page automatically generated from multiple files together, or is it a company internal program?
Right. So just run back a few slides here. So I guess the fundamental core elements well, first of all, we've used Bentley ProjectWise to capture the right versions of the information, and then there's been a bunch of very clever stuff done to melt all of that information down together into the one digital pool of data that sort of links everything together. And then we've developed the web application that then is able to present all that information back to people. Hopefully that answers the question.
Okay, so another question, if you could add more information in the interface, what would you want to be there? Like more views or more data?
That's almost not a question for me, all right? Because what I try to emphasize to people is what we've done is just data. So whatever data you have that is associated with anything that you're working on, we can capture it, melt it down, and then present it back in whatever format you might be interested in. So it really does depend on the application that you might be interested in. So I've had people want to look at again from a through life support perspective, the possibility of capturing maintenance records for the sake of the argument, better than traced through to the asset. That's probably one example that I've heard people talk about. But from my point of view, it's just data. So we'll capture it. We've got a range of different widgets from a range of different perspectives. So widgets, as in different boxes in the interface showing a viewpoint. So whatever you've got, I don't really mind. I'm just keen to vacuum up as much data as possible and show as many connections as possible.
All right, thank you. So a third question, thank you for the presentation. Are you able to share any information on the qualification of RESAN, meaning if you followed any particular standards when developing the tool?
Right. So, well, certainly we've got, this is a KBR developed tool, and KBR has got some well-developed standards about how it is that we develop tools that make sure that they are, for example, properly cyber secure. A lot of effort's gone into that sort of thing. Beyond that, I think the interesting thing is less about how the tool is built and more the different standards that are out there in terms of the data. So things like RECIF files that to exchange information with doors, And then you've got the industry foundation class files that are fundamental in the BIM world. There are some very interesting different standards out there. But in terms of and it's learning how to decompose those different data standards is actually sort of the interesting part. In terms of the qualification of the tool itself, like I said, a lot of effort has gone into meeting appropriate KBR standards.
All right, thank you. So we have 1 to 2 million left for the very last question, but last one. So thank you for your presentation. What challenges have you encountered when rolling out RESAN on infrastructure projects, and what have been the key wins and losses from actual implementations? And secondly, how do you see the future of RESAN, and what will be the improvements you can take on this?
Yeah. Okay. I think the key challenge for us from a technical standpoint was getting, and it's not a, yes, so I'll say it's from a technical standpoint, but it's actually an organizational problem, which is getting everybody on the same page in terms of the ontology. Right. I think early on we could see that people were using the same words to mean slightly different things. Right. If you try to merge data when people are using the same words to mean different things, you're in trouble. That's not going to work. So sorting out the ontology as early as possible, that was an important challenge. I think the biggest issue that we avoided outright was any organizational resistance, and we did that by showing the imperative to have a tool like this and making sure that there was planning done up front for budgeting for people to do this sort of work. I could probably go into a lot more detail, but I have to be a little bit careful about what I expose. But that I think is probably the sort of key things to get right. Digital is about people, not just data. You've got to get the people right first to get the data right.
All right. So thank you very much, Tim, for this presentation.